This video is about polar equations for conic sections, and in this video I will talk about these four polar equations for conic sections. These are the polar equations for conic sections, where E is called the eccentricity and D is the distance between the focus at the pole and the directrix. For example, this is the pole, which is also the focus. This is called the directrix. The distance between the pole and the directrix, in this case, is 6. So D is 6. The eccentricity determines the type of conic section that we will have. If the eccentricity is between 0 and 1, the conic section will be an ellipse. If the eccentricity is equal to 1, the conic section will be a parabola. If the eccentricity is greater than 1, the conic section will be a hyperbola. Here we have an eccentricity of 0.7, and therefore we have an ellipse. Is eccentricity 0.6, eccentricity 0.5, 0.4, 0.3, 0.2, 0.1. And here's 0.9. And when eccentricity is equal to 1, and then we have a parabola. If eccentricity is greater than 1, in this case is 1.1, and then we have a hyperbola. Once again, if E is between 0 and 1, then we have an ellipse. If E is equal to 1, we have a parabola. If E is greater than 1, then we have a hyperbola. And now let's take a look at D. D is the distance between the pole and the directrix. In this case, the directrix is vertical and to the left of the pole. If we have a vertical directrix to the left of the pole, then the corresponding polar equation would be R equal to ED dividing by 1 minus E times cosine of theta. And now let's move the vertical directrix to the right of the pole. So this is a vertical directrix to the right of the pole. Then the corresponding equation, polar equation, will be R equal to ED dividing by 1 plus E cosine of theta. The directrix could also be horizontal and below the pole. Then the corresponding polar equation will be R equal to ED dividing by 1 minus E sine of theta. If the horizontal directrix is horizontal and above the pole, then the corresponding polar equation will be R equal to ED dividing by 1 plus E sine of theta. Here we have eccentricity equal to 1, and therefore the conic section is a parabola. The vertical directrix is to the left of the pole. Therefore, the polar equation will be R equal to ED dividing by 1 minus E cosine of theta. Vertical directrix to the right of the pole. The equation will be R equal to ED dividing by 1 plus E cosine of theta. Horizontal directrix below the pole, the equation will be R equal to ED dividing by 1 minus E sine of times E sine times sine of theta. Horizontal directrix above the pole, then the polar equation will be R equal to ED dividing by 1 plus E sine of theta. Here we have eccentricity greater than 1, therefore the conic section will be a hyperbola. The vertical directrix is to the left of the pole. Therefore, the polar equation will be R equal to ED dividing by 1 minus E cosine of theta. Vertical directrix to the right of the pole. So the polar equation will be R equal to ED dividing by 1 plus E cosine of theta. Horizontal directrix below the pole, the polar equation will be R equal to ED dividing by 1 minus E sine of theta. Horizontal directrix above the pole, therefore the polar equation will be R equal to ED dividing by 1 plus E sine of theta. And now let's take a look at how how it affects the shape of the conic section. So here I have an eccentricity of 0.6. Therefore we have an ellipse, and the directrix is the line, vertical line, x equal to negative 10. Now let's change it to negative 9. And now let's move the vertical directrix to the right side of the pole, and then change D. And now let's move change the horizontal, and make the directrix horizontal below the pole, and then vary the D. And then now let's move the horizontal directrix to so that it's above the pole. So here's D equal to 3, 4, 5, 6, 7, 8, 9, 10. And here we have a eccentricity equal to 1. And with directrix, the vertical line x equal to -10. And once again, if eccentricity is 1, then we have a parabola. And so this here's the directrix, x equal to -7, -6, -5, -4, -3, -2, -1. And now let's move the vertical directrix, and let's move it to the right side of the pole. And now let's move it, make the horizontal directrix, make it below the pole. And now the horizontal directrix above the pole. So here we have an eccentricity of 3, and therefore we have a hyperbola, and the directrix is x equal to -10. And now let's change the directrix. And now let's move the vertical directrix. Let's move it to the right side of the pole. And now let's make the directrix horizontal and below the pole. And now let's make the directrix horizontal and above the pole. And so in summary, the eccentricity, if it's between 0 and 1, we have an ellipse. If it's equal to 1, we have a parabola. If it's greater than 1, we have a hyperbola. And then the location of the directrix, if it's to the left, if it's a vertical directrix to the left of the pole, then the equation will be of the form r equal to ed dividing by 1 minus e cosine of theta. If the vertical directrix is to the right of the pole, then the equation will be r equal to ed dividing by 1 plus e cosine of theta. And if we have a horizontal directrix below the pole, then the corresponding equation will be r equal to ed dividing by 1 minus e sine of theta. And if we have a horizontal directrix above the pole, then the equation will be r equal to ed dividing by 1 plus e sine of theta. And that's the end of the video.